Welcome everyone to live stream 58 of our Space Shooter DevVenture. So in our last session, we had just about finished testing off our, let me just get to the point where we were over here. We still need to consider the case where the actor is under threat. So we've gotten the point to a point where interrupting our current behavior with an emergency behavior seems to be working, right? Now, the next steps, as we can see here, phase 2, is that we can add a simple danger sensor for the AI ship. And that's not necessarily the most important thing right now. What we do need to consider, though, oh, no, this is my mistake. No, this is important. Of course, this is important. We want to add a collider or an area 3D around the AI ship, all AI ships, right? That will allow for collision avoidance. And what we want to do here is check for objects of a certain group. That's the word I was looking for. Objects within a certain group, right? So if it's a mining object and the AI actor is well, basically not a mining vessel, right? So if the AI actor is of type defender or type pirate, then look for objects of type mining object. And if the AI actor is of type mining vessel, then of course look for objects of type target, right? Not AI objects, not mining objects, of course. So things that you can collide with that are not mineable, right? And that basically fits under the category of everything else. So if it is not a mining object, so if it's a mining vessel and the object in the area collision is not a mining object, i.e. it cannot be mined, it cannot be destroyed by any means that the mining vessel possesses, you know? As Gandalf said, the ring cannot be destroyed by any means that we here possess, right? So at least that's my best recollection from the movie, not necessarily from the books. Anyway, small digression. So if the mining object is unable to deal with, in quotes, deal with the object being about to be collided with, avoid it. So fight or flight response. Either you fight with the thing that you're colliding with by shooting it or mining it, or however you can, and if it's not possible, then flight, right? Flee, move away, avoid it. And so that's what we need to do. We need to have that phase 2 implementation done, right? Now, firstly, before we continue, I do have to apologize for missing yesterday's live stream session. I was busy with some other things, and I never managed to get a message out in time to let you know that I wasn't able to make it. So my apologies for that. But to make up for it, I'm going to do back-to-back live streams today, right? So today, this live stream session, the normal one, and then immediately after that, I'll do another one. All right? Which means I'm going to have to end the live stream a little earlier, this one, to give me that chance to prepare the next live stream starting at 3 o'clock my time. And that means this won't be a full hour, but the next one will be. And we should be able to get a lot more done because there aren't any interruptions except for live stream transition, right? And I'll be here and my time is dedicated to this and to you, which means I'm not going to be leaving my desk. I'm not going to be doing other things. I'm not going to be switching to other projects. And so we should be able to make more progress because context, right? it's always a thing when you come back to a project. It's always a bit of a cognitive load to figure out, where was I? What was I doing? What do I need to do? Oh, yes, that's where I was. That's what I need to do. And that takes a few minutes. And of course, it takes a lot of brain power. Unless you have records like this on Perplexity that can help you. But as you can see, we've taken 5 minutes now just to get to the point about what exactly we're going to do. So without any more deliberation, let's get into this. Okay, so I'm going to add a danger sensor like they recommend to the various ship types, right? And then the AI actor is going to have access to that. The AI actor will have access to that, and the player controller will have access to that as well. However, the player will not have the luxury of automatic collision avoidance, right? The player will instead have an early warning notification system saying, hey, by the way, there's something in front of you. You can't destroy. You better avoid it. You're on a collision course for something you can't fight with. You have to fly. You have to flee. And so that would be the best thing for the player. Of course, you don't want to make any kind of overbearing choices when it comes to the player. The player wants to have the freedom to do what they want to do, even if it means harming themselves slightly or fully. You obviously just have to give them that opportunity to realize, hang on, you realize that what you're doing is going to hurt you. And if they say, yes, that's fine, I understand, but, I'm going to be a little childish and do it anyway, then, it's not real. So they're not really hurting themselves. Although, if we do allow that kind of behavior, we do need to have some kind of public service announcement saying, don't do dangerous activities in real life. But we'll get to that when we get to that, right? Right now, we're just prototyping. And prototypes can be a little bit more bare bones without the frills. But like I said, no more deliberation. And then what do? I go and deliberate. So I'm going to move this over to the side and have it off screen, but I can refer to it when I need to, and then we can get on with the work, right? So in testing seek behavior, we are currently dealing with the pirate ship. Okay, and so we need to first work on the pirate enemy because that's the one we're dealing with. And the best way to do this is to just add an area 3D node and add that on, right? So as you can see here, we want to make sure that any component that isn't or rather that is any component that is directly referenced by the root level script needs to be only one child level down. So child, not grandchild, not great-grandchild, and not anything further than that. It just has to be one tier down from the root. And the reason for that is just because it's easier to access, right? It makes things more modular. It's easier to access, easier to think about, and easier to script, right? And yes, it does look a bit, dense. But what you can do is you can make, like with Gun Pirate, you could make it its own scene and give it a script. And then cause, by signals or some other means, you could communicate with that scene's root node and let it handle its children. You know, so you want to, for example, have access to all the wing thruster lights, make them. Forget about that. You want to have access to all the wing thruster lights and the tail thruster light, or you want to have access to all the lights, but you don't want them all to be like this. You want them to either be in some kind of array, or you want to have them grouped together in a scene and then have a script that manages them. You could do that too, right? It's just a matter of choice. Now, I need to add on that collider before I start talking too much again and waste, well, not waste, but use up a lot of our time. Because again, well, not again, but I haven't mentioned this to you before, but I've said this before. So I'll say it to you guys for the first time. It's only a waste if it's misplaced, right? So the time is only a waste if it's misplaced. So if I took that time and used it in a way that would be considered misplaced, that's a waste. And yes, it rhymes on purpose. So add a child to the enemy ship route. We'll call this area 3D node. We'll create that area 3D node. We'll give this a name. We'll call this danger sensor as recommended by Perplexity, right? So danger sensor. Maybe don't use the underscore. Danger sensor. Okay, and the danger sensor needs a collider, as you can see here. There is no shape, so it can't collide or interact with other objects. So let's go ahead and add a shape to that. The danger sensor needs a collision shape, and we'll just collide. The collision shape needs a shape. We'll add a sphere shape 3D, and now it's happy, right? It's got a sphere shape collider, and all we need to do now is set the size. Okay, now the ship itself is quite large, and you can just about see the sphere over here. But we want this collider to be quite big, right? Now I'm going to set this to something like 10 meters. That's a bit small. So maybe, actually, I'm just thinking about this for a second. Should it be a sphere? Should it be a sphere? Because surely the ship only flies in the forward direction, and it rotates according to the forward direction. It steers like a car, basically, right? It doesn't, well, it doesn't even steer like a car. It steers more like a plane, actually. It doesn't even reverse. So it doesn't really have much up and down movement. It doesn't even have a lot of strafing. It's literally just like that. And I am thinking maybe it shouldn't be a sphere. It should be something more like a cylinder, you know, where it has a rough avoidance radius like this, but a much bigger avoidance radius like that. So let's give it a different shape. We'll give it a capsule or a capsule shape. Maybe a capsule shape, because it gives you that like spherical thing in the front, or just a cylinder. And then we just add to the height, change the radius to be like 10. No, 10. Oh, I see. Okay. Now we can rotate this thing in the transform. We'll just change the rotation along the x-axis to be 90 degrees and shift its position forward to be -10. Right, so you've got this like 10 margin over here, and so something can kind of almost sneak up on it, but not quite. And then maybe, should it be a sphere? I mean, a cylinder? What other shapes do we have? A concave polygon, a convex polygon, a capsule, a height map, a cylinder, a box, a sphere, a separation ray shape 3D. I was hoping to have something like a frustum or a pyramid we could have used. Doesn't seem to have that shape just there available for us. Fine, we'll use the cylinder, but we'll change the radius to be smaller, something like 5 meters instead, right? Because again, the ship is quite small, and that is ample space, more than enough space. And then obviously we don't want this thing to be too large, so we'll set that to 20 and push this back somewhat. Keep it at the center. $15. What do you think? Do you think that's a good avoidance shape? Collision avoidance? Or should I do a capsule? Let's try a capsule, why not? Let's play around with the shapes for a while and see which one looks nicest. Radius 10. Was it 10? I think it was 5. And a height of 15. Kind of spherical. Kind of spherical. But also not quite. So if I take the danger sensor now and I move it back so that it's kind of like this. Now I think that works nicer. We've got this like look ahead property, but also have this like spherical protector around the ship, you know? Now I think that's fine. And I'm going to save that, and then that's done, right? Now we could do the same thing with the player and with the, not the player, but with the defender and the mining vessel. We can do the same thing, right? However, I just want to make sure things work with one and then expand to the rest. So let's go ahead and test it on this one, and then obviously we can expand. Again, we use the Shreknik, right? And we build up layer by layer. So we've finished the initial stage. Now we just have to add the code. And coming back to Perplexity for a second, we've added the danger sensor. And when the sensor reports an obstacle is within the danger radius, then we call start the override behavior on the ship's manager and let the flee run. And then this phase gives you the behavior you originally described, where the patterns that auto pause when a non-target obstacle is too close, and then resume once clear. Right? Now that's cool. And if we go back to phase 3, which is later, we can do robust multi-obstacle avoidance, where we look at clusters of obstacles in the way and determine the best direction to avoid them all, right? might not be necessary. We'll see how it goes. It depends on how densely clustered they are, right? Because you might just be better off allowing the ship to do some kind of ping pong maneuver, right? Where it goes ping pong, ping pong, ping pong, and out. Because detecting all of the asteroids in that cluster, because they're so far apart, is probably going to become too expensive. And by expensive, I mean computationally expensive. It's going to take too many operations, take too long, and cost you, right? Or cost the player their frame rate or additional electricity consumption or whatever you want to use to determine cost of the computation. So let's ask Perplexity to go ahead with phase 2. Let's go ahead with phase 2. Full stop. I've already implemented the danger sensor area 3D node and gave it a capsule collider, capsule shape 3D for the collision shape. Here are the, or rather here is the updated scene file for a detailed reference. Okay, now I can save the scene, then I can go to file system and under scenes, entities, pirate enemy, open this in a file manager. I'll just copy this code and paste it into Perplexity. Okay. Now let's go ahead with the scripting aspect of this phase. As usual, tell me where to add the code, and I'll add it. As you can see, the capsule shape 3D is offset slightly, so there is a better look ahead for the AI actor because it flies like a plane, not a car or a tank. So spherical collision detection is a little excessive. Right, so the next step is to let the danger sensor tell the NPC behavior manager there's a nearby obstacle. Run, flee as an override without touching patterns. This lives best on the ship or a small sensor script and calls into the manager. Add a script to danger sensor. Create a new script, for example, resources scripts npc ai danger sensor.gd. And then we have this kind of code which does the following. Extends area 3D, class name danger sensor, optional. Filter by groups to decide what counts as danger. Export danger groups, array of type string name, and then assign values like obstacle, mining target, or whatever, right? And then we've got variables like enemy ship, which is of type enemy ship, and the behavior manager is of type npc behavior manager. Then we've got the ready function. We've got is danger body and trigger flee from and on body entered and on area entered. Okay, so these are the codes and where to attach it. If you, or rather in your enemy ship root scene, select the danger sensor node and attach this script file to it, and no other scene changes are required. Then ensure that danger objects are tagged, and then confirm that the NPC behavior manager override API is ready. Okay, so let's deal with this in the 3 steps. So step 1, step 2, step 3. Okay. Step 1 would obviously be to write this script file. So I'm going to move this off to the side again, and under scripts, I'm going to create a new script in npc ai and call it danger sensor or rather uppercase danger sensor.gd. Okay, then inherits we'll just create it. We'll open up danger sensor.gd. We'll copy the script and paste it all in like that, right? And now of course we have to do the typical alignment of the columns, right? So here we've got the grouping, you know, grouping export variables together, grouping plain old variables together, and grouping onReady variables together, which is already done for us, which is good. Now all we have to do is shift type declarations all to the same column, which I'm busy doing now, like this. And then remember that the assignment operator needs to go beyond the longest type declaration, and so that means going up to 60 at least, right? And so that means this one has to go to 60 as well. It has to go to 60 as well, like that. And then I want to see something. Yeah, so we can actually zoom out, but looking at the screen, I'm not sure that's a very good idea. So I think that's better, just so that it's easier for you to see, for you guys to see it. Right now, I want to move the, here we go. We can move this off to line 30 and this off to 60. Okay, that's fine. We can do this one and then set this to 30 as well, and then seems like everything's in order. Yes, yes, there we go. And that's that. So I can save that file, and then on danger sensor we can attach that script. So go to the file system, danger sensor, attach the script there. All done. Okay. For those of you who couldn't see that, I'll just drag this up because my coffee.com link is in the way. So we just attached it here. You can see there, dangersensor.gd. Okay, it's still out. There, dangersensor.gd. Okay, so now I'm going to go ahead and see what step 2 is. We've got step 1 done. Step 2 is to ensure the danger objects are tagged. Okay, now we're going to have to go back to testing seek behavior in the 3D scene. Excuse me. And then now what I want to do is add in some mining objects and also add in maybe 1 or 2 other collision objects that can't be destroyed, right? Now, if I go to nodes and I check the groups here, we've got mining objects, targets, and that's about it, right? Now, I need to add in some mining objects. And I wish there was a better way to do this. So what I'll do here, I'm going to spread these waypoints out a little bit better, because as you can see here, it's quite crystalline and not the very best way to spread out shapes, right? Because this is hypotenuse and this is not. As you can see, I tried to fit the waypoints according to a cube, but of course that's not going to work the best, is it? So what I'm going to do now is I'm just going to go and determine what is the hypotenuse for a cube and get that distance and shift each one out by the same distance, right? So it should be root 2 for these ones and root 3 for this one, right? Times whatever unit that is. So what unit is that? Let's just go and check. On the transform, it's 30. Root 2x, root 3x. So the square root of 2 times 30. Or the cube, no, the square root of 3 times 30 is the square root, the cube, the square root of 90. The square root of 90 is not a trivial answer. The square root of 90, can it be? No, can't possibly be. The square root of 90 is not 90. Okay, there we go. 9.5, basically. No. That's not how it works. Oh man, that's not how it works at all. My apologies. I was on some weird line of thought there. It's Pythagoras in 3D, right? So it's a squared plus b squared plus c squared equals d squared. Because you got 3 axes. So you got x squared plus z squared plus y squared equals h, which is the hypotenuse squared. And so it would be 30 plus 30 plus 30 squared each. So 30 times 30 is 900. Okay. So that's 900 plus 900 plus 900 equals 2,700. And we take the cube root of that, right? And so the function this to 1 over 3 equals so it's 2,700 all to the power of 0.333 or a third, right? So is that right? Or is it the square root? So 2,700. No, it's the cube root. It's the cube root. No, you know what? I'm not I'm not sure about that one, and I don't know the answer off the top of my head. So let's just go and figure this out at another time, because we're just going to take too much time, and if we do that, it will be a waste because it will be misplaced. This is not important right now. So but do you know what? We can actually figure out this distance is 30, 30, 30, right? And that distance there from 0 to 30, 30, 30 is the square root of 2,700. I think it is the square root. Just double check this. So 2,700 square rooted is about 51. Okay. So if I set each of these to be 51, and this would be the square root of 900, but we'll set this to be 51. Does that look equally distant? Kind of. Now the only one that isn't on the sphere anymore is this one here, right? And so if we know that it's a 51 circle, right, we can calculate what the x squared value will be, if we just open up Krita for a second, I can calculate this very, very quickly. Because we got let me just change the pen color. Change the pen color to white. We change the pen size to 3. Okay, now I just want to do this quickly. Got a circle like that. Okay, we've got this line like so. We've got this line like so. That's a 90-degree corner. So we'll just do a little 90-degree marker. Not filled 90-degree marker there, like that. Okay, now what we want to know is, if I draw a line here, we'll change that to now be green. What is that length? Right? Because if I change the color back to white now, if this is 30, it's too thick. If this is 30, and that's 30, so this is 30, and that's 30 there, right? So these are the same length. This can't be the same length, because, I mean, it has to be the same length, but it's not along the x-axis or the y-axis. So it's slightly less than x, as you can see, and also slightly less than y, as you can see there, right? So we need to know this line. So I'm going to change this to be yellow. We need to know what this line here is. If we create a new new right angle triangle, right? Then what is this distance here? Or rather, what is this new distance here, such that x and y are the same, right? Because if this is the hypotenuse, and the hypotenuse has to be 30, right? Or 51, or whatever it is. It's actually 51. So let's change this to be 51. Switch that back to 2. Turn off the pen, change it to white. So this was actually 51, right? So if that's 51 and this is 51, this new value here, or rather this value here, because this value is just the same thing on the y-axis, and it will be the same on both, right? So it will be change back to yellow, 2 and 2, right? So we'll change this line to have double like this, right? Now what I'm saying is that this is 45, this is 45, so this would be root 2 of this distance here, which is x. Okay, so this distance here is x, this distance here is x, and this here is root 2x squared. Because it's x squared plus x squared, so it's 2x squared. The square root of 2x squared is 2x. No, I'm making a mistake. It's the square root of x squared plus x squared, which is the square root of 2x squared, which is literally just root 2x, right? Let me check this. If I go in to Google search and I check is the square root of 2x to the power of 2 is the same as the square root of 2 times x. Okay, so here's the explanation. No, the square root of 2x squared is not always the same as the square root of 2 times x. The expression root 2x squared simplifies to square root of 2 times the square root of x squared, which is equal to square root of 2 times x, right? The square root of 2 times the absolute value of x, and the expression square root 2 dot x is equal to root 2x. These two expressions are only identical when x is non-negative. For any negative value of x, the result will have opposite signs. For example, okay, fine. But I just wanted to check if, okay, no problem. I got my answer. So this is going to be root 2 absolute value x, if you want to be pedantic, Google. So it's root 2 times absolute value x. Okay, now we want to know what absolute value of x was, is 51, because it's on a circle, right? Or rather on a sphere. But it's just no, it's not, because now we know. Okay, now we can calculate this. This is good. Now I can change the color to an orange color. Now we can say this. Okay, 51 is equal to the square root of 2 times the absolute value of x. Okay, and that means that x is 51 over the square root of 2. So x is equal to 51 divided by root 2, which is equal to, drop my pen there, let's calculate it. 51 divided by 2 square rooted is 36.06, so about 36. Okay, so what I'm going to do here, or rather I'll just undo and redo, so we'll say it's roughly equal to 36 units, right? That means 36 units in the x, 36 units in the y, and that will give us our rough 51. So now if I click back on waypoint 9, I can change this to be 36, 36. And this one also 30, 30, 30. That's fine, because that gives you the 51. And then everything else is okay, right? Because this is 51. And it looks spherical to me. Anyway, like I said, this isn't crucially important. I just wanted to do a little bit of a exploration on that, some maths DevVenturing. Now I've got my spaceship set up, or rather my pirate ship is set up. My waypoints are spread out more spherically than they were before. They were cubic in their dispersal before this, and now they are more spherical in their dispersal. Of course, you can see they are still clusters here, especially over there. It's like a constellation over there. But now what I can do is I can add in some mining objects. So let's do that, right? And I'm literally not going to care where I put them or where they end up, as much as I did for the waypoints, because the waypoints matter a little bit more, right? Because they need to be spherical almost, because of the way that the seek algorithm works, right? So that is in scripts. I want to add on an asset or scene. Yeah, scenes, components, general components. Oh no, these are behavior components. General components, mining target. Okay, so here we go. I can add these in. Okay. And then press F for focus. Oh, I see. It's just positioned all the way up here. So now all you have to do is relocate it. It's not hard, but it's also not trivial. So I'm going to call this mining object 1. And then we can rename these as we go. Put it in the way. Now, remember the thing with mining, with the mining objects, is they don't actually show up in the scene except their little health bars until you run the test, and then they are visible, right? So if I run the scene now, you should see it as a light blue box in the way. Okay. Now, if I press spacebar, or actually no, we'll take the quickest and easiest route and say go around like this. What? Oh, yeah, of course. It's not been it's not been set up for any of that code, has it? If I open up the script editor, you should see on the danger sensor, on body entered, if not danger body area, if area is node, if body is an enemy ship. I was just reading this in Perplexity. I should have brought it onto the screen. So step 2 is that we need to have a filter by grouping, right? So for the filter to work, obstacles you care about must be in a group. For asteroids or non-destructible objects, add them to, for example, obstacle in the editor. And for targets that should work or should trigger avoidance, like mining objects, we add them to mining target, right? So this matches the default danger groups, obstacle, or mining target. And you can adjust that list per ship in the inspector. Okay. I should probably add a group called obstacle. And then it would make more sense, and it would be easier to do the logic, the collision logic, for all the various types of ship types, right? Because if you do just the mining object, you're going to have to check, is it a mining object or is it not a mining object? And is this it's actually no, it's actually quite simple, because it's, are we dealing with a mining vessel? Yes. Okay. Then is the thing that entered the body a mining object? No. Okay. Therefore, do avoidance, right? Whereas if it's not a mining vessel and it is a mining object, do avoidance. So it's just a quick little flip-flop. So I think that's fine. Then we confirm NPC Behavior Manager Override API is ready. The code above assumes your NPC Behavior Manager GD already has start override behavior and this. So you've already implemented those steps earlier. Just verify the method name and signature match. And with this in place, when the danger sensor's capsule overlaps an obstacle or mining object or mining target, it will call start override flee. The manager will pause the current pattern, run flee as an override, and then resume the pattern after flee completes exactly as designed, right? So going back to GD script here, we've got these functions. Enemy ship, get parent as type enemy ship. If it's not an enemy ship, right, then push an error, danger sensor parent is not a type enemy ship. If enemy ship has node NPC Behavior Manager, we get the node NPC Behavior Manager as type NPC Behavior Manager. Otherwise, we push an error that says we couldn't find it on the parent ship, right? And then we connect body entered, the signal for body entered, to the function on body entered. The same thing for area entered, we connect to on area entered, and then we write our functions, right? So if the function is danger body, checks the body, returns a bool. So if not body, return false, obviously, because the body is null. If danger groups is empty, return true. And then for G in danger groups, if body is in group G, return true. Okay, so now that means we need to have this danger groups set up. Mining target and obstacle. It's not mining target, it's mining object. And we can save that. And that's why it didn't work, because we didn't say mining object. Okay, so if it's not a mining object, or rather if it is a mining object, return true. So now we can see if not is danger body, then return. And if body is enemy ship, then return, right? And if body is no 3D, then trigger flee from body. Oh, I see that we've reached the hour for this live stream, and unfortunately, I allowed things to go a little bit longer than I intended. So I'm going to close off this one, and then we'll start immediately with the next one. So thank you so much to Cubes for your support. It means a lot. And to everybody else, please do check coffee.com/mtkdev to support the channel. There are membership tiers, and you can do once-off donations. And you can join the Discord server. The link's in the description. Thank you so much for your time and your attention, and I'll see you in the next one, which is right now.